My name is Abby, and today we are going to be talking about polarization. Polarization is the separation of charges in an object that remains neutral. This means you have both positive and negative charges floating around in a conductor, which is neutral, that for some reason or another decide to separate. There are a couple of different ways we can do this. One way we can do this is through a method called induced polarization. Here, I'm drawing two metal conductors that are in contact with one another, but they're insulated from the rest of the world. These are neutral conductors. Inside, we have positively charged ions, as well as negatively charged ions. Here, we have a negatively charged rod, but how did it become like that? The plastic rod is initially neutral. In order to change this, you can rub the rod with some wool. This will cause electrons on the wool to be transferred to the rod, leaving the wool with a net positive charge and the plastic rod with a net negative charge. Now what happens when we bring a negatively charged rod close to these conductors? Well, just like magnets, opposites do attract. So the positive ions move closer to the rod, and the negative ions are repelled by the rod. This is similar to magnets. The closer you bring a positive and negative magnet to each other, the harder it gets to keep them apart. You can physically feel the attraction intensify. This intensity of the charge shift is based on the distance between neutral conductors and the charged rod. The closer the charged rod is, the stronger the attraction. As a result, we get a separation of charges, with all the positive charges on the left and the negative charges on the right. All the while, the conductor is still neutral because the amount of charge has not changed. Next, we're going to show you a couple of experiments that you can try at home. All you'll need is some hair, which will act like our wool from earlier, as well as a comb, which will act like our plastic rod, and a faucet of running water, which could just be the sink in your kitchen or in the bathroom. We're going to show you two different experiments that represent polarization. So for this experiment, you'll just need to use your hair, which again represents the wool from earlier in the video, and a comb, which will represent our charged rod. For this first experiment, we're going to show you how neutral objects can be attracted to any charged object. First, you'll run that comb through your hair, causing the electrons in your hair to transfer to the comb. This makes the comb's overall charge negative and your hair's overall charge positive. Then you'll take a bunch of tiny pieces of ripped paper. These are not drawn to scale. These pieces of paper are neutral, with equal amounts of positive and negative charges. When you bring that comb close to the little pieces of paper, the comb, being negatively charged, causes the charges inside of the paper to reorient themselves so that the positive charges are closer to the comb and the negative charges are further away. As you move the comb closer to the paper, the attraction is actually stronger, which allows pieces of the paper to start floating towards the comb. For our second experiment, you'll just need a steady stream of running water, as well as that negatively charged comb from earlier. So let's talk about water for a second. Water is a naturally polarized molecule. This is due to the fact that there is one oxygen atom and two hydrogen atoms. The oxygen is more negative, and the hydrogens are more positive, making this molecule slightly polar. In this second experiment, you'll have your sink going with a steady stream of water. These little dots are going to represent our water molecules. We can see right now that we have the oxygen on top with the hydrogens on the bottom. So what's going to happen when you bring your negatively charged rod, or comb, close to the stream of water? Like we've seen before, the water molecules will reorient themselves, just like the little pieces of paper, so that those positive hydrogen atoms are closer to the negative rod. What happens is you get this new orientation here, with the oxygen far away from the rod and the hydrogens closer to the rod. This change in orientation causes the water to actually bend towards the rod. It's a little exaggerated here, but you get the point. upload videos of you guys trying these experiments and let me know how they worked for you.